Hey guys, what's up? I'm back with day 16. Really big, important video today. The topic of discussion is called the chain rule. So the chain rule is what we use, just like product rule and quotient rule and power rule. It's a rule for derivatives, but chain rule is for the derivative of a composition of functions. So it could also be called the composition rule, but pretty much everyone in calculus calls it the chain rule. So here's what this is for. It's for the compositions of two functions. So here's the rule in its just general f and g form. So it's for taking the derivative of f of g of x. This is not f of x times g of x. That would be the product rule. This is a function g of x embedded within a function f of x. I like to think of g of x like the inside function. And f of x like the outside function. So if you're asked to perform a derivative of something, and it looks like it's got an inside and an outside, we should be thinking chain rule. Right? If we're asked to take the derivative of something and you know it's a composition of two functions, again, it's going to be a chain rule to solve it. So here's the rule. We do the derivative of the outer function, in this case f, but it's the derivative of the outside with respect to the inside. So it looks like this. So it's the derivative of the outside with respect to the inside multiplied by the derivative of the inside. So again, this is the derivative of the outside with respect to the inside times the derivative of the inside. I'm going to write down those words on here as well so you have them for your notes. You may be a little bit confused what I mean by derivative of the outside with respect to the inside. But as we look at some examples, this rule is best understood by just looking at lots of different examples. One thing I want you to notice, it's not f prime of g prime of x, it's just f prime of g of x. Another thing that I'll refer to if you're stuck is right away the inside stays the same. So that initial part of the chain rule here, the inside is going to stay the same. Then we chain on, right, or tack on the derivative of the inside. So both g of x and g prime of x show up here, where f never shows up again. Okay, goes straight to f prime. Okay, so let's take a look at this as an example. And I'm planning on doing 1, 2, 3, 4, 5, 6 examples. And as we see these 6 examples, hopefully we'll start to get a little better understanding of how the chain rule works. So here's example 1. So we have the function f of x equals sine of x to the fifth. And again, I'm asking you to find f prime of x. So I want to do the derivative here. Now, if you look at this, you might say, well, isn't this just a product rule? Sine x times x to the fifth? But it's not sine x times x to the fifth. It's sine of x to the fifth. We have an inner function here and an outer function. Our inner function is this x to the fifth. This is my inner. My outer is sine x. If I wanted to write this as a composition of two functions, let's say g and h, I could say, so we do g of h of x. You don't have to do this every time. I'm just going to kind of relate it back to right up here in this area. So h of x now is representing my inner function. H of x here would be x to the fifth. My outer function g would be sine x. So then if I did g of h of x, I'll just write it right here. It would be sine, but not of x, because that's g of x. G of h of x, I'd replace the x with the function h of x, which is x to the fifth. Okay. But again, I want you to think of this as x to the fifth here as our inner function and sine as our outer function. So here's what we're going to do. We're going to do f. We're going to find f prime here. We're going to execute the chain rule. I'll use a different color so it stands out. So I'm going to do the derivative of the outer function. The outer function here is sine. The derivative of sine x is cosine x. But I'm not doing the derivative of the outside with respect to x. I'm doing the derivative of the outside with respect to g of x. So what I get here is I get cosine for the derivative of my outer function. But instead of being with respect to x, I'm doing it with respect to my inner function g. So it's cosine of x to the fifth. That's the derivative of the outside. That's what I mean by with respect to the inside. The inner function was x to the fifth, and it stays x to the fifth in this part of the chain rule. Cosine of x to the fifth. Not cosine of x, not cosine of 5x to the fourth, cosine of x to the fifth. Okay? But I'm not done with the chain rule. I have to multiply by the derivative of the inner function. Well, my inner function is x to the fifth. The derivative of x to the fifth is 5x to the fourth. So I multiply on 5x to the fourth. Times, it's not plus, it's times 5x to the fourth. And there we have an accurate derivative. Now, I'm going to take a second here to rewrite this because I like to have my polynomial stuff out front. Right? Coefficient comes first, followed by polynomial stuff, followed by the trig function cosine of x to the fifth. And this is my accurate derivative right here. I get 5x to the fourth cosine of x to the fifth. Okay, but again, I did the derivative of the outer function with respect to the inner function times the derivative of the inner function. Yeah, this is like the g prime, this is like g, and this is like f prime of g. Okay. Let's take a look at another example. Okay. So when I take a look at this function, again, we might not recognize it as a composition yet, or we might think of it like, oh, cosine x to the fourth. But remember what this cosine to the fourth x means. Anytime we see this written, before we get really used to this, I want you to rewrite f of x here as the quantity cosine x to the fourth. this literally means, again, I'm going to label this f of x because I haven't done a derivative yet. I'm just going to rewrite this as the quantity cosine x to the fourth power. Okay? When you write it like that, it's a little bit easier to see what's inside and what's outside. Now, our trig function in example 1 was the outer function, but now it's hopefully clear to see that that cosine of x is the inner function. Now, cosine of x is our inner function. Our outer function is like x to the fourth. But instead of it being x to the fourth, it's cosine x to the fourth. Okay? So my inner function is cosine x. My outer function is like x to the fourth. So if you think about it, we have to start with derivative of the outer function. The chain rule starts f prime of g of x. We do the derivative of the outside with respect to the inside. Well, if our outer function is like x to the fourth, we know the derivative there, just using the power rule, would be 4x cubed. But that's the derivative of the outer function with respect to x. I need to do the derivative of the outer function with respect to the inner function. Again, these are a lot of crazy words here. The more you see this, the easier it'll get. Okay? Come back and rewatch this video again tomorrow or the next day, and it'll start to make a little bit more sense. So here's what I'm going to do. I'm going to execute the chain rule for this problem. And I'm going to say the derivative of the outside, right, is 4x cubed. But I don't want it to be with respect to x. I want it to be with respect to the inside. Remember how I said the inside stays the same? So this inner function just needs to stay the same, just like that. So cosine to the fourth power, its derivative is going to start off as 4 cosine cubed. Okay, that's the derivative. That's f prime of g of x right there, derivative of the outer function with respect to the inner function. And now I just have to multiply by the derivative of the inside. And I know the derivative of cosine x is negative sine x. And what I don't want to write here is just minus sine x, because now it looks like subtraction. Remember, the chain rule chains on with multiplication. So we're multiplying by negative sine x. And again, I like to write that with parentheses, so I can clearly see in my work that this is multiplication and not subtraction. Okay. And that is my derivative. That's the derivative of the outside with respect to the inside times the derivative of the inside. Now I want to clean this up here to report this in a nice way. We see this a lot on the multiple choice, and they would never write it like this. They're going to write a more simplified version. So here's what they might do. Now we have two separate trig functions here. We have sine x and cosine x. So I'm going to look at my coefficients. I have a coefficient of 4 and a coefficient of -1. And I'm multiplying those together. So I'm going to multiply them together and put it out front as -4. Okay. Now this cosine x cubed is probably going to be written without parentheses as cosine cubed x times sine x. Remember, this negative was thrown out front. It's right here. So this would be most likely written as -4 cosine cubed x sine x. Okay? So that's our nice, simplified, concise way of writing the derivative there. Good. Let's take a look at another one. Here's another example. Okay. So I see here I have the square root of the quantity 6x squared plus 5. Now, the way this is written, it's pretty clear to see that 6x squared plus 5 is our inner function. Our outer function then is like square root x. Just like when we did just the derivative of square root x, it's going to be helpful to write the square root as an exponential power. And we know that a square root means half power. So let's go ahead and rewrite this thing as f of x equals. Notice I'm not doing the derivative, so this remains f of x, not f prime of x. I'm going to write this as the quantity 6x squared plus 5 to the 1/2 power. Again, here's my inner function. Here's my outer function, which is x to the 1/2 power. So to execute the chain rule here, I'm going to do f prime of x equals. I'm going to do the derivative of the outer function with respect to the inner function. So that inner function is just going to be copied down below. So I'm going to take this 1/2 and multiply it out front, and I'm going to get half. And my new power is going to be -1/2. Right, that's the derivative of the outside. To make it with respect to the inside, I have to keep that inside exactly the same. Notice I did not do the derivative of the inner function yet. That comes at the very end. I did the derivative of the outside with respect to the inside. And now all I have to do is multiply by the derivative of the inner function. Well, the derivative of 6x squared plus 5 is simply 12x. That plus 5 goes away on the derivative. And there I have the correct derivative. Again, derivative of the outside with respect to the inside times the derivative of the inside. Cleaning this up here, I see I have a 12x and a 1/2. And these are, again, connected with multiplication here. Half times 12x is going to be 6x. Okay. And again, I could write this right now as 6x times 6x squared plus 5 to the -1/2. But I don't like leaving negative powers, so I'm going to drop this down to the denominator and say f prime of x equals 6x over. Now it's going to be 6x squared plus 5 to the positive 1/2 power, which I know means a square root. So it's going to look something like that. Okay. I cannot cancel anything here because all that stuff in the bottom is tied into the square root. Wouldn't be able to anyways. But there's our derivative. Okay. 3 more examples quick, and then we'll be done. I'll move a little bit faster through these examples. Let's look at example 4. So I have a function e to the 4x squared plus 5. What I'm going to do here is I'm going to think of this 4x squared plus 5 as my inner function. Inner. And I'm going to think of my outer function as e to the x. Now, the nice thing about e to the x is its own derivative. So the derivative of e to the x is e to the x. But when I go to do the derivative of the outer function, remember, it's always the derivative of the outer function with respect to the inner function, which is not x here. So here's how this is going to look. So I do the derivative of the outer function, which is its own derivative, but it's with respect to the inner function, 4x squared plus 5. E derivatives are going to do this a lot. The derivative starts off by basically just copying what you already have. That's the derivative of the outside with respect to the inside, 4x squared plus 5. And now we just need to multiply by the derivative of the inner function. The derivative of 4x squared plus 5 is 8x. Okay, and that's the correct derivative. Simplifying this a little bit. By the way, make sure this term right here is obviously not part of this exponent here. So make sure your exponent is written as a superscript and that 8x is written on the same plane as the e is. And to make that less confusing for our readers, we're just going to take that 8x and put it out in front and call f prime of x 8x e to the 4x squared plus 5. Okay. Let's look at example number 5. 2 more. Problem 5 is f of x equals the natural log of 5x cubed plus 2. And again, I'm asking you to find f prime of x. Again, I'm going to identify this as my inner. My outer function is going to be ln x. Well, I know the derivative of ln x is 1 over x, but that would be the derivative of the outside with respect to x. I want to do the derivative of the outside with respect to the inside. When I do this one, I'm going to end up with f prime of x equals the derivative of the outer function is 1 over, but instead of 1 over x, that's the derivative of the outside with respect to x. I need the derivative of the outside with respect to the inside. It's not 1 over x, it's 1 over 5x cubed plus 2. That's the derivative of the outer function with respect to the inner function. And then I just need to multiply by the derivative of the inside. The derivative of the inner function is 15x squared. Cleaning this up, I'm going to write it as one fraction and see if anything simplifies. When I multiply these together, the 15 is just going to go on top, because 15 times 1 is 15, x squared. That's going to be on top, and on bottom, I've got 5x cubed plus 2. Now, you may be really quick to simplify that 15 and that 5, but you can't do it because of the 2. You may be quick to simplify the x squared and the x cubed, but you can't because there's no x term in that plus 2. So that's as simplified as we can make it. And we'll box that as our final answer. Okay, last example for today. Why don't you just pause the video here and see if you can solve this one on your own. F of x equals 6x cubed plus 5, that whole quantity to the 4th power. Okay, we're back. Here's how I would do this one. I'd identify 6x cubed plus 5 as my inner function. My outer function is x to the 4th. So to do this derivative correctly, I would say f prime of x equals the derivative of the outside with respect to the inside looks like this. That's f prime of g of x. And then I just need to multiply by the derivative of the inner function, which is 18x squared. This and this can combine. 18 times 4. 4 times 8 is 32. So I get 72. So f prime of x would be 72x squared times 6x cubed plus 5 cubed. Don't forget about this. A lot of people forget that. Don't forget that the derivative of x to the 4th is 4x cubed. So don't forget, a lot of times people drop that power there. Don't forget to include that with it when you do the derivative of the outside with respect to the inside. And here's our final answer, and that's it for today. Okay, kind of a longer video, but a very, very important one. This is one to, if you're ever struggling with the chain rule, come back and rewatch this video. I'll see you guys tomorrow. Bye.